This question then says changes over equal intervals. Write an equivalent expression with as few terms as possible. So basically simplify, combine like terms, however you'd like to say that. So anytime you have parentheses, the first thing I would do is distribute. So I'm going to change that to 2p. And 2 times 1 is, of course, 2. So now I'm going to combine like terms. So I'm going to combine the p's. I have a 7p and a positive 2p. That is a total of 9p. And then I'm going to combine the whole numbers. I have a negative 3 and a positive 2, which would combine to
1. Because you got a negative 3 and a positive 2. So you get 1. Or negative 1.
negative 1. Negatives are bigger there. Of course, those are not like terms, so you cannot combine them and say 8p. That is a common mistake. It has to have the same letter on it to be a like term. Number 2.
Would you put in parentheses because it's negative?
No, not needed. Minus 1 or plus a negative 1 would be the same thing. So you could write it either way. If you want to write it like that, you can. Question number 2. Again, I'm going to distribute, so there are no parentheses. 4 times n, please. 4 times 1. Just 4. I still have that 10. There's not anything multiplied by that 10. There's not anything multiplied by that 10, so I'm just going to leave it as 10 right now. I'm also going to distribute the negative 4 and get rid of that as well. So negative 4 times n. And negative 4 times 1. All right, what can I combine there?
4n.
4n minus 4n. Nothing. Negative 4, positive 10.
10.
Just 10. So your answer to that whole thing simplifies nicely to just 10. Question number 3 is reviewing the rules for exponents. If I have the same base and I am multiplying, remember what you do to the exponents? Add them. So 5 plus 2 plus x. So I have 7 and the x. I remember I cannot combine them and say 7x. So I'm just combining like terms again. Add up the whole numbers, the x has got to stay.
Wouldn't x be 1 so then it'd be 8?
Doesn't tell you what x is. If x was 1, it would be 8. But it just says x. How about when you divide? Remember what you do there? You subtract the exponent. So I have 4n minus 1n. 3n is correct. Page 427, number 2. Amy, would you read that one, please?
Here's a graph of y equals fx, where fx equals 2x plus 5. How does the values of x change whenever x increases by 1? For instance, when it increases from 1 to 2 or from 19 to 20. Be prepared to explain and show how you know.
All right, what is happening to our y value, our f value, it's saying? Remember, that's the same as y, right? So as our x's get bigger by 1, as I move to the right, it's going from 0 to 1, 1 to 2. What's happening to my other number is what it's asking. Yeah, it's increasing by 2. Your f or your y, however you want to say that, is going up by 2. And that's going to be the same for 19 and 20. Why? Because it's linear. It is a line. So that will always be true. Don't waste time going all the way to 19 and 20. Question number 2. Georgia.
Through this question, we can use to find the difference in values of f when the input changes from x to x plus 1. Does this expression have the same values as what you find in the previous questions?
All right, so we just answered and went up 2. Let's see if we get the same answer when we simplify this. We just did one like this for number 1. Again, first step, get rid of the parentheses. 2 times x. 2 times 1. 5 still is by itself. Negative times 2x. Negative times 5. All right, again, just combining like terms now.
So 5 and the negative 5 can cancel.
2x and the negative 2x cancel. And Georgia said the 5 and the negative 5 cancel, so what are you left with? 2. Is that the same as what we said on the previous page?
That was 10.
You said the answer was going to be 2.
Oh, I thought you were talking about number 1.
No, it was just using the equations of that line. Slope of 2, starting at 5. Question number 3. How do the values change when you increase x by 4? Let's go back and check the graph and see what our prediction is. So increasing by 4 would be going from 0 to 4. That would be 4, 13. So how much did I go up by? 8. 2, 2, 2, 2. Adds up to 8. So if we're increasing by 4, we said every time it happens it increases by 2. You could also said 2 times 4 is 8. That's my prediction. I think it's going to go up by 8. So let's check it. We're going to use this exact same equation that they have so nicely for us. But instead of x plus 1, we're going to use x plus 4 because we're going up 4. So I'm going to write the exact same equation. Except it's going to say x plus 4. Everything else is going to stay the same. And again, that's just comparing the original equation with one slid up 4. So I'll let you try that one. Why don't you distribute that? And what should our answer be?
2,
8. Should be 8, because we went up 4. We just answered that. So if you do it correctly, you should get 8.
I got 2.
C was actually telling us to solve it or show it, so we actually did that as well. Should be 8. Most common mistake on these types of problems is people forget to distribute that negative sign. They usually do the negative 2x, and they forget about the 5. That negative goes with both of those, so it always has to be negative 2x and negative 5. So make sure you remember to do that as well. 429. Mr. Talp, read that, please.
Here's a table that shows some inputs and output values of an exponential function g. The equation g x equals 3x defines the function. How does gx change every time x increases by 1? Or explain the reasoning.
All right, so 3 to the x power it says we're using. So 3 to the third power, 3 to the fourth power, 3 to the fifth, and so on. But it's saying, how does it change every time this goes up by 1? What's happening to our y value, our g of x here? It's tripling. Right? If you can't see that, You take 81 divided by 27, you could take 243 divided by 81, you could take 729 divided by 243, the one behind it and divided by the one in front of it, you get the same answer. If you can't see it, you get 3. Factor of 3 times 3. Question number 2, choose two new input values that are consecutive whole numbers and find their input and output. All right, well, let's choose 10 and 11. 3 to the 10th. 59,049. 3 to the 11th. 177,147. And wants to know what their factors are there. How did that change? It's still 3. It is still times 3, no matter what two consecutive numbers you choose. Question number 3, complete the table with output values when the input is x and when it is x plus 1. All right, well, if it's x, it's just going to be 3 to that power. And then to show that it is 1 bigger, it's going to be 3 to the x plus 1 power. Now, do we still agree that it'll be a factor of 3 here? Well, it should be. Those are consecutives. 4 wants you to prove it. So let's take the second one divided by the one in front of it, just like we did for the other ones. And now back to problem 1. What do you do when you divide and the bases are the same? You subtract the exponents. So it's going to be 3, and then I'm subtracting these. X plus 1 minus the bottom. 3 to the first power. Again, it is a factor of 3. That is basically a proof for why it works. Will always be the case. Consecutive integers will always be times 3. Question 5. Choose 2 x values where one is 3 more than the other. For example, 1 and 4. How do the output values change as it increases by 3? So let's check 1 and 4. 3 to the first, 3 to the fourth. How many times bigger do you think that second number will be? Before we actually figure it out. 12. I disagree with that.
27.
Why?
Because I just put it in the calculator.
Oh, George, I cheated. I said try it first.
Because 3 times 3 equals 27.
Yeah, each time you go down, it's getting 3 times bigger, right? So 3 times 3 times 3, that should be 27 times bigger. We can check it. 3 to the first is 3. 3 to the fourth is 81. What's 81 divided by 3? 27. Every step is 3 times bigger. So 27 times bigger if you take 3 steps. Question number 6. Complete the table. Same thing. Now it has an x plus 3 instead of x plus 1. We went 3 steps further. All right, so the first question is going to be 3 to the x still. Second one is 3 to the x plus 3. What answer should I get here again? Should get 3 to the third power or 27. Let's check it. 1 below it, divided by 1 in front of it. Again, the rules state that you subtract the exponents. Top minus bottom. Simplify. Combine like terms. X's will cancel, and you're left with 3 to the third, which is 27. Again, a proof of why that works. You can write skip by the Are you ready there? Page bottom 461. Get right into the homework. See if there's any we need to discuss here. Says whenever the input of a function increases by 1, the output increases by 5, which equation will be? That means if I plug in 1 to the equation, I plug in 2, my answers are different by 5. It is only true for one of those. You can just plug in 1 and 2. Let's just pick this one. 5 to the first is 5. 5 to the second is 25. Do those increase by 5? No, so that one's out. You know, that's all you do. Until you find one that works. Question number 2, circle the word all. Again, more than one answer there. Question number 3, I think you can handle. Question number 4 is just like what we did today. Question number 5. If you are looking for things that will be a good measure, you are going to be looking at lines. Remember, exponents, exponential functions is tough to find a good domain of what to show of your graph, good averages, because it increases so much. So just look for lines there for number 5, linear functions. 6, I think you can handle. Next page, final page. 7 is multiple choice, what we did the last few days. I think you can handle that. Question number 8. We have 4 linear functions. Write a verbal description as what is done to the input to get the output, and then write the inverse. All right, so let's do one of these. Certain one you want to do? D. Okay, so what am I doing to the input? What am I doing to the x there? I am dividing by 4, so that is my description. And then it wants the inverse. So what is the opposite of dividing by 4? Multiplying by 4. So I'm going to take my d of x, or my y value, times 4. I'll just use d of x since that's what they did. So you're just solving for x in these problems. Do the opposite. So opposite of dividing by 4, there's my inverse function. So this one you can use symbols or write it in words. This one is asking for the inverse. So it should be 8 answers for that one. So 6 additional ones. We just did 2 of them. And that'll be due tomorrow.